Hello friends, let us now learn some important points about intensity of X-ray beam. Intensity of X-ray beam is defined as the number of photons in a beam multiplied by the energy of each photon. So number of photons into energy of each photons is called as intensity of X-ray beam. So this is given by the units Rontgen per minute or coulombs per kg in SI system. So the intensity of X-ray beam depends upon four main factors. One, the target material. Second, kilovoltage applied. Third, filtration. Fourth, tube current. So first, target material. Target material, higher the atomic number of the target atoms. That means if the atomic number is more, then there is more efficiency in the production of X-rays. So more Bremsstrahlung radiation is seen. So higher atomic number target atoms produces Bremsstrahlung radiation. So if you take tungsten, when compared to tin, tungsten has an atomic number of 74, tin has an atomic number of 50. So tungsten has higher atomic number when compared to tin. So as a result, tungsten will produce more X-rays when compared to tin. That is, more quality X-rays and more quantity of X-rays are produced by the tungsten when compared to tin. So for Bremsstrahlung radiation, the atomic number of the target material determines the quality and quantity of the X-rays produced. The quality and quantity of X-rays produced are determined by the atomic number of the target material in Bremsstrahlung radiation. So atomic number of the target material determines the quality, quantity and also the energy of the characteristic X-rays also. It determines the energy quality of Bremsstrahlung radiation and it also determines the energy and quality of characteristic X-rays also. So K shell characteristic X-ray for tungsten, which has an atomic number of 74, is 57 to 69 kilo electron volt. For tin, which has an atomic number of 50, it is 25 to 29 kilo electron volt. For lead, which has an atomic number of 81, the characteristic X-rays are between 72 to 88 kilo electron volt. So next, molybdenum target. Molybdenum target has lower atomic number anode. So if you see, the normally tungsten target has higher atomic number of 74. Okay, and it has higher energy or K shell binding energy of tungsten is around 70 kilo electron volt. Whereas molybdenum has lower atomic number and at low tube voltage it produces less Bremsstrahlung radiation. And if you see tungsten, it produces more Bremsstrahlung radiation. Whereas the molybdenum will produce less Bremsstrahlung radiation and it produces more important characteristic or photoelectric effect, characteristic radiation or photoelectric effect. It produces more characteristic radiation. So because of its lower atomic number and lower tube voltage, it is used in breast radiography, that is nothing but in mammography. In mammography, molybdenum target is most commonly used. The maximum tube voltage of mammography is 70 kilovolt peak. So 17.5 kilo electron volt, that is K alpha, and 19.6 kilo electron volt, that is K beta. Both these are the characteristic radiations of molybdenum. So molybdenum produces characteristic radiation of 17.5 kilo electron volt has K alpha and 19.6 kilo electron volt of K beta. So the maximum total radiation produced from the molybdenum target is 17.5 and 19.6, and this is used for mammography. So the next important thing after target material is voltage applied. This is the second factor which is affecting the intensity of radiation. As the wavelength increases, so this is wavelength, so this is intensity of X-rays. If we draw a graph between the intensity of X-rays and the wavelength, as the kilovolt peak or voltage applied increases, the energy increases. At low voltage, there is less intensity. At high voltage, there is high intensity. If there is high intensity, more X-rays are produced. So if we increase the voltage applied across the cathode and the anode, that is if we increase the kVp, more energy of electrons are seen. So the electrons have more energy, and if there are more energy of electrons are seen, more X-rays are produced. So this is important. So intensity of X-rays, if you see the formula, intensity of X-rays is directly proportional to kilovolt peak whole square. So here the wavelength is constant. Okay, next. The third factor affecting the intensity of X-rays is X-ray tube current. As the X-ray tube current increases, the intensity of X-rays increases. So if this is the cathode and this is anode and this is the kilovolt peak which we have seen. Now X-ray tube current is the uh, electrons flowing from cathode to anode. So this is tube current. So as the tube current increases, more electrons are emitted from the cathode. There is more X-rays are produced because more electrons are emitted, so more X-rays are produced. So this is has milliampere second, that is the tube current increases, more intensity of X-rays are produced and more X-rays are produced. So these are the important points about the factors which affect the intensity of X-ray beam. Filtration we will learn in our next class. So target material, kilovolt peak and tube voltage have been dealt. Thank you.